Hey everybody, so today what we're talking about is geometric sequences. So recall what we've done so far in this chapter is arithmetic sequences and arithmetic series. Now remember the difference between a sequence and a series is that a sequence is a list of numbers. A series is where you add that list of numbers. Also, arithmetic is when there is a common difference. So like to get the next term, you would add 6, add 6, add 6, or subtract 4, subtract 4, subtract 4, right? So what we're talking about today is geometric sequences. A geometric sequence is a sequence in which the ratio between successive terms is called a constant, okay? So this is called a geometric sequence. So the key word here is the ratio. The constant is referred to as the common ratio, so they don't call it a difference here, they call it a ratio, because difference means like plus 2, plus 2, plus 2, or minus 5, minus 5, minus 5. A ratio doesn't mean that, okay? So these three sequences are geometric sequences, okay? They are not arithmetic. So I want you to find the common ratio and then find the next three terms. Go ahead and do this. I think the only one that you're going to have a problem with is number 3. So I will show you how to get the ratio if you don't know how to get it just by looking at it. Okay, so this one here, if you look at the pattern, okay, so first off, if I thought it was arithmetic, I can see that it's minus 12 and then plus 24, so definitely not arithmetic. But if you look, this is times negative 2 times negative 2 times negative 2. So the common ratio, since it's multiplication, is negative 2. And then to find the next three terms, I would keep on multiplying by negative 2. So you should get 64, negative 128, and 256. All right, this one here, you should see that this is plus 6, then plus 18, so it's not arithmetic, but it says it's geometric in the direction, so that's not difficult. But times 3 times 3 times 3 times 3, so R is 3. And then the next three terms, I'm going to keep on multiplying by 3. So you get 729, 2,187, and then 6,561. Okay. So the next one here, of course, my notability freezes. Wonderful. It's a wonderful day when that happens. No big deal. It happens to everyone, right? I hope it does. I hope it's not only me. Okay, so the next one here, I see that, like if I'm looking to see if it's arithmetic, this is plus 7, and then this is plus 19, so it's not arithmetic. But then I'm asking myself, what do I multiply 4 by to get it to be 11? Right? So now I'm like, 2 point something, and I just don't know what it is, right? So I want to look back at these right here to think, looking at these first two terms, how can I get a negative 2? Negative 8 divided by 4. Looking at these two terms, how can I get a negative 2? 16 divided by negative 8. Negative 32 divided by 16. Those are all negative 2. 9 divided by 3, that's 3. 27 divided by 9, that's 3. 81 divided by 27, that's 3. So that's where our common ratio comes from. To get your common ratio, you can just take the second term and divide it by the first term. So here, we can check for it first. Take the second term, which is 11, divide it by the first term, which is 11 fourths. So I'm thinking that R is 11 fourths. Now to check it, what I'm going to do is I'm going to continue to multiply by 11 fourths. So if you put in your calculator 11 times 11 fourths, you get 30.25. I read this as just a 32 seconds ago, but obviously it's not arithmetic. You get 30.25. If I multiply this by 11 fourths, I get this 8.1875. All right? So your common ratio is 11 fourths, or you can say that that is 2.75. It's the same thing. It's as long as it wasn't a repeating decimal and then you simplified it, it's fine whether you write it as a fraction or a decimal. All right, so now I'm going to get my next two numbers. So I'm going to put this in my calculator, and then I'm going to multiply either by 2.75 or 11 fourths, and then just the fastest way to do this is just keep hitting times 2.75 times 2.75, and it'll take the last thing that was in your calculator and keep multiplying it by 2.75. So you get 228.765625. Then you get 629.105. And then 1730.040. I wrote down all the decimals that were on the screen because it didn't give me rounding directions. But if you rounded to 3 decimal places, that's fine. Okay? All right, so I froze again. This is just, if anyone has any tips, go ahead and send me an email about why my Schoology keeps freezing, or my Notability. Okay, so how do we write a rule for a geometric sequence? It's actually easier than an arithmetic sequence. Okay, here's the formula. It's a sub n, so that's what we call it, just like having like y equals, right? It's just a sub n equals. That's just like your output. A sub 1, which what does that mean? That's your first term. Times r, that's your ratio, to the n minus 1 power. And that's your formula. One thing people accidentally, so for example, a formula would look like this for geometric: 2 times 4 to the n minus 1. Realize this is 4 to the n minus 1 times 2. It's not, you can't say like, oh, I'm going to simplify that to 8 to the n minus 1. That's not a thing. Okay? Okay. So, what do I need to write a rule of a geometric sequence? That's the question that I always ask myself. Oh, and there's a typo. I see it right there. 5 years strong. This says arithmetic. That's wrong. This is supposed to be geometric. Still haven't changed it. Keep forgetting. Okay. So to write a geometric sequence, you need 2 things. You need the first term, and you need the ratio. All right, so I have to remember that that's the 2 things I need. If I have those 2 things, I'm good to go. Write an explicit rule for the nth term of the sequence, and then it says it's 12.5, comma 5, comma 2, comma 0.8, comma 0.32. Then find a sub 8. So first off, I got ahead of myself here. They didn't even tell me it's geometric. So let's see if it's arithmetic or geometric. So to get 12.5 to be a 5, I would subtract 7.5. But if I subtract 7.5 from 5, I don't get 2. So it's not arithmetic. Now let's see if it's geometric. What do I multiply 12.5 by to get it to be a 5? No clue. So I'm going to go ahead and write it as a ratio. I have 5 over 12.5, which that is ugly because it's a decimal inside of a fraction. So I'm going to go ahead and pop that in my calculator. And I get 0.4. All right, so I'm going to continue to see if it's 0.4. So now I'm going to check, is 5 times 0.4 2? It is. Is 2 times 0.4 0.8? It is. So now I know r is 0.4. My first term, 12.5. Got it. All right, so here's my rule. A sub n equals a sub 1, 12.5, times my ratio, which I like to put it in parentheses because otherwise it looks like this, 0.4, like that. Like it's just not good looking. So I like to put the ratio in parentheses, 0.4. It's the n minus 1 power. Especially if it's negative, it looks horrific. Okay, so there's my rule. I got my rule. Write an explicit formula. That's done. Then it says, then find a sub 8. So remember, to find the 8th term, all I have to do is plug in 8 into my formula. So I'm going to do 12.5 times 0.4 to the 8 minus 1 power. Now, instead of putting 8 minus 1 power in my calculator, I'm clearly going to change it to a 7, just because otherwise I need it in parentheses. It gets crazy. So my calculator, 12.5, parentheses, 0.4, close the parentheses, to the 7th power. This will give me my 8th term. I should already know that it's going to be a really small number. Okay, so I'm going to write down every number that shows up on my calculator to give an exact answer. 0.02048. Now, it doesn't say whether to write my answer as a decimal or a fraction, but these are decimals, so I'm just going to leave it as decimals. Okay, next one. One term of a geometric sequence. Okay, so now they told me it's geometric, so I need the first term and I need the ratio. One of the terms is the fourth term is 3, and that's not the first term. Common ratio is 3. Well, thank you for that. Write an explicit rule for the nth term. Okay, so I was not given the first term, but I was given that the fourth term is 3. So what I'm going to do is I'm going to use this formula, and I know that when I plug in 4 for n, I get 3 here. So I can start by using that. Okay, so I'm going to say a sub n, which I get 3, so 3 equals my first term, which I don't know, and that's what I'm trying to find, so cool, times ratio, which I do know my ratio. My ratio is 3, so that's 3 to the, this was my fourth term, so 4 minus 1 power. All right, so how is this helpful? Well, because I can find my first term now. All right, so make sure you're doing orders of operations. So first work with your exponent here. 4 minus 1 is 3. All right, so now I have 3 to the third power, which is 27. So I have 3 equals a sub 1 times 27, or 27 times a sub 1. You can write it either way. It doesn't matter. To get a sub 1 by itself, I'm going to divide by 27. And then instead of turning that into a decimal, because it's not a nice decimal, I'm just going to simplify the fraction. 3 goes into itself once. 3 goes into 27 9 times. So 1/9. So now I can write my formula, my rule, since I have these two things. A sub n equals my first term, which is 3, times my first term, which is 1/9, my bad. My first term, which is 1/9, times my ratio, which is 3 to the n minus 1 power. Okay? All right, next one. Two terms of a geometric sequence are a sub 2 is -4, a sub 6 is -1024. Write an explicit rule for the nth term. So they did not give me the first term, they did not give me the ratio, but they gave me the second term's -4 and the sixth term is -1024. Now, if this was arithmetic, I can say, oh, it's a line. I can say when I plug in 2, I get -4. When I plug in 6, I get -1024. The thing is that this is not a line. Geometric sequences aren't lines. They're exponential functions. Why are they exponential functions? Because there's an exponent there's a variable in the exponent. That's an exponential function. Okay? So what I'm going to do is I'm going to, just like I said on this one right here, well, I can't do anything but plug in those values. That's what I'm going to do here. I know that when I plug in 2, I get -4. So once again, I'm using that formula. I'm going to write it right here so you don't have to look back up. A sub n equals a sub 1 times r to the n minus 1. All right, so what I'm going to do is that I know that when I plug in 2, which is right there, I get -4, which is right there. And I know that when I plug in 6, which is right there, I get -1024. So I'm going to go ahead and write my two equations that I get. So my first equation is -4 equals, I don't know what a sub 1 is, times, I don't know what r is, to the n minus 1. So that's 2 minus 1, or you can just erase that and just put first power. All right, my other equation, -1024 equals a sub 1 times r to the n minus 1. 6 minus 1. Or I can just erase that and put fifth power. Ooh, that's not going to be helpful. Okay. All right, so I have two equations with two variables, and I need to solve it. How do I solve an equation? Sorry, how do I solve, this situation that is two equations with two variables? Now, I called it a situation because I didn't want to accidentally call it a system and everyone be like, oh, yeah. You're going to use substitution or elimination. Okay, that's how you solve a system. Now, you cannot use elimination on this. Elimination can only be used when you have a term plus a term equals a number. Okay, so there is no addition in this, so we cannot use elimination. We're going to have to use substitution. All right, so we're going to go to our first equation. What we're going to do is we're going to solve the first equation for a sub 1. Okay, so if I asked you to get a sub 1 by itself, how would you get a sub 1 by itself? divide by r to the first power. All right, so now I know that a sub 1 is equal to negative 4 over r to the first power. All right, now that I know that, I can substitute this in for a sub 1 right here. So now I have negative 1024 is equal to negative 4 over r to the first times r to the fifth. All right, now I have to clean this up. First thing I'm going to clean up is r to the fifth divided by r to the first. What you have to realize is that since this is multiplication, this is just like one big fraction right here. So r to the fifth divided by r to the first. Remember, with our exponential rules, we keep our base and we subtract our exponent. So that's r to the fourth. Or there's 1 down here. I get rid of 1 from here. There's 4 left. So I have negative 1024 equals negative 4 times r to the fourth. Divide by negative 4. I get 256 is equal to r to the fourth. And now I have to fourth root both sides. Now remember, when you even root, you have to account for the positive and negative answers. So I'm going to get 2 answers for r. Now, fourth root on your calculator, there's what we have to remember is that, like, if I did the square root of 25, that's the same thing as 25 to the 1/2 power. So the fourth root of 256 is the same thing as 256 to the 1/4 power. So go ahead and try that. Make sure you're getting the same answer as me. Okay, so you should get that it is plus or minus 4. You could have also square rooted twice, but if it was fifth root, you can't do anything about that. So that's why you need to know how to do it. Okay, so now I know that r is 4. So I can solve for a sub 1. A sub 1 is equal to negative 4 over, I'll do positive 4 first, and I get a sub 1 is equal to negative 1. So I'm actually going to get 2 equations here. My first equation is a sub n is equal to a sub 1, which is negative 1, times r, which was positive 4 to the n minus 1 power. Second equation, a sub n is equal to, I haven't solved it yet, so let's do that. So a sub 1, negative 4 divided by, let's do the negative 4 now. And I get that that's negative 1. So, or sorry, positive 1. So my next equation is 1 times 4, negative 4, to the n minus 1. So either one of these equations works. Let's look at the directions. Write an explicit rule. So if you only did this one, you're okay, because it just says write an explicit rule. It doesn't say write more than one explicit rule. But either one of those works. Okay, so the rest of this, from my recollection, is just practice. Yes. Okay. So I'm going to redo these problems with you. I think it's a good idea, instead of saying like I got it and leaving, just to like sit through these. I'll go fast though. Determine whether the following, or have it open and you try this first section and compare with mine. Okay. Determine whether the following sequences are arithmetic, geometric, or neither. Go ahead and pause the video. Do those 3. All right, this one. This is -7, -7, -7. So this is arithmetic. And the difference is -7. Oh, also, just as an FYI, I am not pronouncing arithmetic wrong. It is arithmetic. It is spelled the same way as arithmetic, but it is not the same meaning. Okay, next one right here. If I look, this is +2, then +4, so it's not arithmetic. And then I look at times 2, and then times not 2. So this is neither. This here, -7, this is not -7, so it's not arithmetic. So I have to ask myself, 8 times what gives me 1? 1/8, I can say that in my head. But if you didn't know that, you could always say, I think it would be, or I would going to check to see if it's this divided by this. 1 divided by 8 is 1 times 1/8, 0.125. If you don't know, you can check on your calculator. It is. And 0.125 times 1/8, this, it is. So it is geometric, and the r value is 1/8. Okay, so go ahead and pause the video. Try the first one. It's not telling you if it's arithmetic or geometric. Remember, you have to check. Okay, if you want to compare it to mine, first I'm going to check to see if it's arithmetic. So I always check arithmetic first because it's just easier. That would be plus 12. And then I would check in my calculator's negative 101 plus 12. And yes, it is. So this is plus 12, and then plus 12, yes. So plus 12. Therefore, this is arithmetic. A1 is negative 113. And then I just need the common difference, which is 12, to write a rule. So no big deal. Now, the directions don't say write a rule. It just says find the 314th term, but you need a rule to find the 314th term. So I'm going to write a rule first. A sub n is equal to, remember, you're switching to arithmetic now. Arithmetic, once again, as a reminder, is your first term plus n minus 1 times d. Okay, and yes, you can make a compilation of all your formulas. We will do that on the review day for the test or the assessment. But it's nice to start organizing them yourself right now. All right, so a sub n equals my first term, which was negative 113, plus n minus 1 times 12. Remember, for arithmetic, we want it to look like a line. So distribute. A sub n equals negative 113 plus 12n minus 12, and then combine like terms. So the rule is 12n minus 125. Right, so that's my rule, and now I can find the 13th term. 12 times 13 minus 125. Now, technically, I could have plugged in 12 right here and got the 125 right away, but there's no harm in writing your rule and getting practice for it. All right, so you should get 3,643. All right, next one. Find the 17th term of the sequence. So first off, once again, pause, try it yourself. All right, so I need to know if it's arithmetic or geometric so I can write a rule. All right, so checking with my calculator, what do I do to 0.1875 to get it to negative 0.75? I would have to subtract, and that amount is not the same as this amount, so it's not arithmetic. Now I'm going to check to see what negative 0.75 divided by negative 1.875 is. All right, I get that is this was positive right here. Here we go. So this is negative 4. So then I'm going to check here. Is negative 0.75 times negative 4 3? Yes. Is 3 times negative 4 negative 12? Yes. So my ratio is negative 4, and my first term is 0.1875. So now I can write my rule for my geometric sequence. All right, remember geometric is in the form a sub n equals a sub 1 times r to the n minus 1. So a sub n equals my first term, 0.1875, times r, which is negative 4, to the n minus 1 power. Rule done. All right, so that's what's nice about geometric. Like once you have your rule, that's over. Okay, now I need to find the 17th term. A sub 17 equals 0.1875 times negative 4 to the 17 minus 1 power, which I'm going to change to 16. And now I can just put that in my calculator. So I'm typing 0.1875 parentheses, negative 4, close it to the 16th power. All right, you should get the answer. 805,306,368. Now I only put commas in so I say it out loud correctly. You don't need the commas though. Okay, next one. Two terms of an arithmetic sequence are the 8th term is 17, the 16th term is 41. Write an explicit rule for the nth term. Then find the value of n, which a sub n. So this is a follow-up question. I'm not going to bother reading it right now. I'll do it when I'm done. Okay. If you look at the next problem, two terms of a geometric sequence are the third term's 36 and the sixth term's 972. So these are both where I didn't give you the first term. I didn't give you the difference for number 3, and I didn't give you the ratio for number 4. Okay, both of them can be solved using systems, but I don't use systems for arithmetic because I know my answers align. So I use the fact that I know that when I plug in 8 to that line, I get 17. When I plug in 16 into that line, I get 41. I just use this method because it's just easier, right? So to write an equation of a line, I need the slope. So I'm going to do 41 minus 17, y2 minus y1, over x2 minus x1, 16 minus 8. All right, so 41 minus 17, 41 minus 20 is 21, plus 3 is 24, divided by 8 is... Okay, so you should get, yes, you should get your slope is 3, okay? Which, remember, that's your common difference, that's D. All right, but you don't need to write that down. It's just, it's one of the things you found. All right, now I can use the formula y minus y1 equals m times x minus x1. And I can plug in either one of these points. I'm going to choose the smaller point and the slope right here. So y minus 17 equals 3 times x minus 8. Y minus 17 equals 3x minus 24. Add 17 to both sides, and I get y equals 3x plus, minus 7. All right, now if I said write an equation of a line, this would be done, but it said write an explicit rule for the nth term. So now I just have to write it as a sub n equals 3n minus 7. All right, there was a follow-up question. It was, for what value of n do you get 914? So when a sub n is 914, what is n? So add 7, you get 921 equals 3n. Divide by 3, and you get n equals 307. So that's the 307th term, 914 is. Okay, so the last one is very similar to example 3 right here. So if you want to use example 3 to model it and try it on your own and just look over it really quickly, you can. Okay, but I'm going to show you it again. So when it's geometric, you cannot say like, oh, I'm going to write an equation of a line. You have to use substitution. So I know that when I plug in 36, I get 3. So I'm going to write 36 equals a sub 1 times r to the n minus 1. So 3 minus 1 power. I'm going to erase that and change it to 2. And then I know that when I plug in 6, I get 972. So 972 equals a sub 1 times r to the 6 minus 1 power, which is 5th power. All right, so now remember, you're going to use substitution. You're going to solve the first equation for a sub 1. So how do I get a sub 1 by itself? Divide both sides by r squared. Now you're going to take this and substitute it into this equation. So now I have 972 is equal to 36 over r squared times r to the 5th. All right, remember now this is multiplication, so this is like one big fraction. So now you're going to simplify this. R to the 5th over r squared. There's 2 down here. Get rid of them. Get rid of the 2 from here. So now you have 972 equals 36 r cubed. Divide both sides by 36. You get 27 equals r cubed. To get r by itself, you're going to cube root. Now remember, when it's an odd root, you do not have to do plus or minus. So what is the cube root of 27? It is 3. The reason it's not 3 and negative 3 is because 3 times 3 times 3 is 27, but negative 3 times negative 3 times negative 3 is not 27. All right, that's why there's only one answer. All right, so now I can find a sub 1. I'm going to do 36 divided by r, which is 3 squared. That's 9. 36 divided by 9 is 4. So now I can write my rule. a sub n is equal to a sub 1, which is 4, times r, which is 3, to the n minus 1 power. All right, that's it for today. Notice there was a lot of review practice in there, but now you can go ahead and get started on your homework, which is book